Good morning, youngsters. Hope you're having a good morning. Um, I wanted to start today with a quote. I miss quote of the day, don't you? This is the quote. Who wants to read it? Who wants to read it? So funny. I'm so funny. I crack myself up. Okay. Art quote of the day. Art is the objectification of feeling. Herman Melville. One, two, three. So, yeah. Who wants to share on it? You guys can share on Google Classroom if you guys want. Um, But what I'm going to do, art is the objectification of feeling. My family is filled with artists. My dad had art all over the house. He was very good at drawing. A lot of my family is like that. They can draw really beautiful pictures, and I have a hard time making a stick figure look good, right? So a lot of times, whenever we think of art, we think of something like that. But um, as I saw this quote, I was just thinking that art is just creativity. We all are different. We all have a creativity inside of us that's different than everybody else's. So my thought was that our artwork is ourselves. Anything that we create is our art. So it doesn't matter what that is. It could be your personality. It could be whatever you do. It doesn't matter. That was my thought. Is that can I draw awesome figures like my family? No. But am I different in a lot of other cool ways? Absolutely. So that's what I would want to spend my time during my day looking for, is where I create unique things from myself. So I wonder what you're really good at. I wonder, um, yeah, that's it. That's funny. I wonder. See my hat? I wonder what you're amazing at. It says art is the objectification of feeling. We have feelings all day. We see this, it makes us excited. We see that, it makes us mad. So it's like just to be aware of that and see what makes you come alive will point you towards your art, so to speak. And those are my thoughts on the quote. And now let's get to some math. All right, solve a side. Solve for a side in right triangles. This goes exactly with one of the Khan Academy skills. You'll be getting another video tomorrow about finding angles. And I think that'll be the last set of videos. So let's get started on this one. Solve for a side in right triangles. Okay, so here we go. We're solving for this side right here. If you don't mind, I'm going to get rid of the question mark. I'm going to turn it into an X. Okay, so it's giving me angle B. It gives me this angle right here. Angle, the 35-degree angle. So let me remind you, SOHCAHTOA. So sine is opposite over hypotenuse. So the sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is SOHCAHTOA. Just that little reminder, that really helps, doesn't it? So in this angle, what is it giving me? It's giving me angle B. I notice it's giving me the hypotenuse. So I automatically know I'm not going to be using tangent. I'll be using sine or cosine. Well, in relationship to angle B, it is giving me the adjacent side and it's giving me the hypotenuse. And when I say it's giving me the adjacent side, what I mean is that that's the side I'm solving for. So I have two pieces of data here. I have that this angle is 35 degrees and that the hypotenuse is 6. Therefore, I can easily solve this. So what am I going to use? Well, sine of 35 would be the opposite side over the hypotenuse. And then I would be able to find this side, but that's not the side I want. I want the adjacent side. I'm solving for the adjacent side. So I'm going to use cosine. Okay. So I'm going to say cosine of 35 degrees equals adjacent x over hypotenuse, which is 6. All right, so now what we need to do, we're going to cross multiply. I can put cosine of 35 over 1, and then all I'm going to do here is I'm just going to cross multiply, and this will help me solve for x. So I'm going to cross multiply these. So 6 times the cosine of 35 degrees equals 1 times x. So we can see we already have x isolated. So x is just going to equal whatever 6 times the cosine of 35 degrees is. Now, in my previous video, I talked to you about this right here. Cosine of 35 is just a number. It's a ratio of sides. And it actually just equals exactly that, a ratio. So what we're going to do, we're going to go to the calculator. Let me see again. 6 times the cosine of 35 degrees. So 6, you need to make sure, see over here on your calculator, you need to be clicked in radians mode. All right? Otherwise it won't work. So 6 times the cosine of, what was my angle? 35 degrees equals 4.91. Khan Academy wants you to round them to the nearest hundredth, so in this case this is 4.91. So x equals 4.91. Now this looks, check this out, let me write this in, 4.91. Look at the relationship between these sides. This side's 6. This side right here is the longest side, excuse me, the hypotenuse is always the longest side in the triangle, but this is the longest leg in the triangle. We can see that it's 4.91. So this number makes sense to me, right? It's almost as big as the hypotenuse, but not quite. So that's about what we'd expect that to be. So there's one of your Khan Academy examples. All right, so next page. We're going to do a bunch of examples. I'm going to speed up as I go, all right? And then you can try them on your own here. So here we go. Sine, I'm going to write my little acronym over here on the side. So, ka, tawa. Boom. All right. So if we look here, I have this 52-degree angle right here. And in relationship to that 52-degree angle, I have this 14, which is the adjacent side to 52 degrees, and I have the hypotenuse. So adjacent, I have the adjacent, and I'm solving for the hypotenuse. Adjacent, hypotenuse. Which one of these gives me those two pieces of information? And that's cosine again. So cosine of 52 degrees equals adjacent over hypotenuse. All right? So, makes sense. Does that make sense? Now what we're going to do, I need to cross multiply to solve for my variable. This one's a little bit more detailed since the variable's in the denominator, but it's still pretty straightforward. So on this side, we're going to get x. Remember, I can multiply in any order I want also. So I'm gonna say x times cosine of 52 equals 14 times 1, or 14. Now how do I solve for x? Well, I need to divide both sides by cosine of 52. So in this case, x is going to equal cosine of 52 Let's go back to that. So X equals 14 divided by the cosine of 52. X equals 14 divided by the cosine of 52. X equals 14 divided by, I'm going to put this cosine of 52 in parentheses just to be safe. So what happened? Why did I get a negative measure? Well, guess what? Remember what I told you about we need to click on radians, all right? So that negative, we can use that as a learning tool here. I got to remember when I use this Google calculator, I need to always click radians, or else it's going to give me some weird answer like that. So 14 divided by, I'm going to do two things with the calculator right now too. I'm going to use parentheses for when I'm dividing, and then I'm going to not use parentheses just to see if it works the same both ways. So 14 divided by cosine of 52 equals 22.74. 22.74. 22.74. I'm going to try this again. 14 divided by cosine, what was the angle? 52, right? I'm not even going to close the parenthesis, and let's see if it gives me the same answer. It does. So 22.74. So here x equals 22.74. So this makes sense. All right, I'm going to do a separate color for this next one. Let's see. This one's giving me, again, it's giving me this 16 degrees right here. So it's giving me the adjacent side, and it's giving me the hypotenuse. Same set of circumstances here. So this is also cosine. 16 degrees equals adjacent side over hypotenuse. It's going to be the same exact situation here. I'm going to cross multiply. So I'm going to get x times cosine of 16 equals 12 times 1. I'm going to divide both sides by cosine of 16. And I'm going to get x equals 12 divided by cosine of 16. 12 divided by cosine of 16. 12.48. This answer makes sense. It's bigger than 12, but not a lot bigger. And because this angle is 16 degrees, we can see the opposite side is super small. So 12 squared plus whatever this is squared equals 12.48 squared. This makes sense. All right, next one. It's giving me this 22-degree angle. It's giving me a 22-degree angle, and once again, well, what's it giving me here? It's not giving me a hypotenuse, is it? It's giving me an opposite side, and it's giving me an adjacent side. So which one of these over here gives opposite and adjacent? It's tangent. So tangent 22 equals opposite over adjacent. Boom. We're going to cross multiply. 19 times the tangent of 22 equals x. Okay. What's 19 times the tangent of 22? Cool. Let's remember to click radians. 19 times tangent 22. Enter. 7.68. We're going to round up on that. 7.68. X equals 7.68. So this side, 7.68. Finally, number 4 here. Now what I'm going to do, I'm going to do 2 things here. I'm going to, you know what, let me just do this one more, and then on the next page I will show you a couple more things. I have a 69-degree angle. In this case, I don't have adjacent. All I have is I have the opposite side and I have the hypotenuse. Okay, so which one gives me opposite? Hypotenuse, that's sine. So let's change the color to blue here. So sine of 69 equals 13 divided by x. I picked some rainbow type of color. I think this is my wife's favorite one she's been using. All right, so okay. We need to cross multiply. Boom. So x times sine 69 degrees equals 13. Now I need to divide both sides by sine of 69 degrees. Boom. So x equals 13 divided by sine of 69 degrees. Boom. Whee! Okay, radian. What was, see, I need to say it again aloud. 13 divided by sine of 69 degrees. 13 divided by sine of 69 degrees. 13 divided by sine of 69 degrees. 13 divided by sine 69 degrees equals, not plus, equals 13.92. Boom. X equals 13.92. Yeah, I'm looking at my answer. It's 13.92 this side. I'm asking myself, does that look right in relation to the longest leg? I'm going to say yes. It's about 1 unit bigger. Once again, this is a really small angle, so it opens up to make a really small side. So I'm going to do, there's 4 more examples on the next page, but I think I'm just going to do one of them. And let's see. I'm going to do a few things here. I'm going to use what we've already learned. Let me also want to make it a little bigger here. Move this over. Boom. All right. I'm just going to do number 5. Okay. It's giving me 64 degrees, but what I'm going to do in this case, I'm going to label the hypotenuse as y. Okay. And I'm going to find this other side, right, or this other angle. If this is 64 and this is 90, remember, if I add up all these angles together, they equal 180. And in a right triangle, what's always going to happen is the two non-90 degree angles, if you add them together, they equal 90. So in this case, 64 plus what number gives me 90? Think about that for a second, or plug it in, or whatever. 64 plus 26. This one's 26. This angle's 26 degrees. I'm going to get really good with this stylus. It's just going to take a few videos. Okay, so now I can find both x and y using SOHCAHTOA. All right, So let's start with x first. I can use any one of these measurements also. So check this out. 26 degrees. I'm going to use this angle. Okay. So I'm going to say I can use, to find x, I can use adjacent over, excuse me, I can use the adjacent side and the opposite side. So tangent of 26 degrees, let me just stop right there in case that might have confused you guys. Tangent of 26 degrees, what would you write next? Okay, what would you write? Tangent is opposite over adjacent. SOHCAHTOA. So opposite is 11 and adjacent is x. So this equation is going to solve for x. So what would I get? I would get x times the tangent of 26 equals 11. I'm going to divide both sides by tan 26, tan 26. So I'm going to get x equals 11 divided by tangent of 26. 11 divided by tangent 26 equals 22.55. So x equals 22.55. So this side is 22.55. Now, how would I solve for y? Well, guess what? I can use either one of these angles, right? If I were using, let's see, let's go ahead and use the 26-degree angle again. Well, I know I have the opposite side and I have the hypotenuse. So what I can use is I can use sine of 26. Sine of 26 equals opposite over hypotenuse. What's opposite of the 26-degree angle? It's 11 over the hypotenuse, which is y. So I'm going to continue the same process here of cross multiplying. Y times sine of 26 equals 11. To solve for y, I'm going to divide by sine of 26. So 11 divided by sine of 26. .09. So y equals 25.09. So this is 25.09. The reason I wanted to solve for all three sides and use different angles is just you're going to be in a position sometimes where you need to fill in extra stuff. The cool thing with SOHCAHTOA is all you need is a side and an angle. You need one of the sides and you need a non-90-degree angle. And if you have that much information, you can find all the sides and all the angles in a triangle. Tomorrow I'll show you how to find angles given sides. All right, so now what would you know to be true in this? Well, you know that 11 squared plus 22.55 squared is going to equal 25.09 squared. You might want to check that math, all right? I know this is 121. It's not going to take long, so I'm just going to go ahead and do this real quick, all right, just to show you. Now, keep in mind, it's not going to line up exactly perfect because we rounded each one of these. but it's going to be close. All right. So 22 point, was it 55? 22.55 squared. Is that a squared button right there? It's not, is it? Well, I guess I'll just do it the old-fashioned way. 508.5025. 508.5025 equals 25.09 squared. $629.5081. These two added together give us 629.5025. See how close these are? See how close these are to each other? Like I said, they're not exactly perfect because we didn't put every decimal place behind them. Had we done that, they would have been perfect. But you can see that we've solved everything correctly. All right. Hope you liked the video.